You think you know the ocean. You've seen photographs, watched documentaries, maybe even dived. But what you saw was the display window. What exists behind it will rewrite everything you believe you know about intelligence, beauty, survival, and life. 95% of the ocean has never been filmed by a human camera. And in the parts that have been, what appeared challenged every boundary science had drawn between the possible and the impossible. Today, you are not watching a documentary. Today, you descend. And what you find down there will permanently change the way you look at the blue horizon. Imagine a city with millions of inhabitants, monumental architecture, sewage systems, markets, hospitals, and trade routes, built without an architect, without a plan, without a government, without a single conscious decision. Coral reefs have existed for 240 million years and are built by polyps, Anthozoa sp. These soft-bodied animals smaller than a human fingernail that secrete calcium carbonate skeletons and stack them over millennia into a structure so dense it is visible from space. The Australian Great Barrier Reef contains more biodiversity per square meter than any tropical rainforest on land, sheltering more than 9,000 documented species. But the city is being demolished. Ocean temperature has risen less than 1 degree Celsius over the past few decades, and that was enough to trigger mass bleaching events that left 50% of the world's corals without color, without symbiotic life, without an immediate future. The oldest metropolis on the planet has a fever, and the cause has a known address. In a tropical reef, there is an apartment that kills every tenant, except one, the clownfish, Amphiprionine sp. Lives submerged among the tentacles of the sea anemone, Actiniaria espedo, whose toxin is potent enough to paralyze fish 3 times its size. The clownfish's immunity is not genetic. It is gradually earned in a careful dance in which the animal touches the tentacles in increasing doses, stimulating its own protective mucus to adapt until it becomes chemically indistinguishable from the anemone's own tissues. In exchange for protection, the clownfish chases away predators, removes parasites, and provides nitrogen fertilizer through its waste. It is a partnership 46 million years old, so ancient that the 2 animals evolved together, each shaping the other's biology. While you read this, the anemone is protecting the fish, and the fish is feeding the anemone. Neither knows the other exists as a separate entity, and yet it works perfectly. Abandoning the shell was the riskiest decision in evolution, and Nudibranchia sp. made it 75 million years ago without looking back. Without rigid protection, exposed in the open reef, these soft-bodied mollusks developed a strategy so audacious that science took decades to believe it. They ingest venomous anemones and, instead of digesting the stinging cells, transport them intact through the digestive system to the surface of the skin, where they store them in structures called cnidosacs and reuse them as their own weapons, literally stealing the enemy's arsenal and incorporating it into their own body. Their explosive beauty, oranges, purples, electric blues, fluorescent yellows, is not ornament. It is warning. In biology, this language is called aposematism, and its message is universal among marine predators. Bright means lethal. Nudibranchs are proof that sometimes the best defense is to turn someone else's attack into your own armor. When the sun touches the horizon and the reef plunges into the golden light of dusk, something emerges from the coral crevices that seems drawn from a feverish dream. The Mandarin fish, Syncharopus splendidus, has no scales. Its skin is covered by a protective pigmented mucus containing cyanophycin, a blue compound that exists in no other vertebrate on the planet, produced internally rather than absorbed from the diet. Its patterns of blue, orange, and green in overlapping spirals are not the result of ordinary pigments. They are nanometric structures that reflect and interfere with light at specific wavelengths, creating colors that high-definition cameras still struggle to faithfully capture. But this visual spectacle has a deadline. It lasts only 40 minutes, the exact length of the species' daily mating window. Male and female rise together in the water column, release gametes simultaneously, and disappear back into the coral before night closes in. Beauty with a set time to begin and to end. On the vertical walls of tropical reefs, color spirals emerge from the limestone like flowers in a submerged garden. But what looks like botany is pure zoology. The Christmas tree worm, Spirobranchus giganteus, fixes itself permanently inside living coral at the larval stage, secretes a calcium tube around its own body, and projects outward two helical cones of structures called radioles, ciliated filaments arranged in a double spiral that slowly rotate, capturing phytoplankton and organic particles in suspension. Each specimen exists in only two colors, always complementary, blue and white, yellow and red, orange and purple, in a fixed genetic pattern that science has not yet fully explained. At the slightest sign of disturbance, both cones retract inside the tube in a fraction of a second, disappearing completely from view. The reef is full of flowers that are not flowers, that feed without a visible mouth, that vanish before being seen, and that most divers go their whole lives without noticing. The emperor angelfish, Pomacanthus imperator, spends its first years of life with a pattern of concentric white and blue spiral stripes, so different from the adult coloration of horizontal yellow and blue stripes that for decades scientists classified them as distinct species. This gradual 2-year color transformation is not merely aesthetic. It signals to other angelfish that the juvenile is not yet a territorial competitor and can move freely through the reef without provoking aggression. When the adult coloration appears, the fish becomes radically intolerant of conspecifics. Each adult defends a fixed reef territory with direct attacks and low-frequency vocalizations audible even out of water. The elegance of the adult coloration, which underwater photographers consistently rank as one of the most beautiful in the ocean, conceals a temperament that combines the ferocity of a hawk with the territorial precision of a lion. The most beautiful is sometimes the most relentless. The surgeonfish, Acanthurus sp., carries retractable spines at the base of its tail, as sharp as surgical scalpels, hence the name fishermen gave it centuries ago. But this arsenal does not exist for hunting. It exists to defend grazing territory. Surgeonfish are the gardeners of tropical reefs, spending up to 10 hours a day scraping algae from coral surfaces with specialized row teeth, preventing algal growth from smothering and killing the reef-building polyps. Without this continuous maintenance, algae would take over the reef within weeks. With ocean warming killing corals en masse and reducing coral cover, surgeonfish now face increasingly smaller grazing territories contested by increasingly compressed populations. An ecological pressure that scientists monitor as an early indicator of ecosystem collapse. The gardener is losing the garden, and without the garden, the surgeon has no reason to exist. Found in love, a survival strategy that no other reef fish has replicated with equal sophistication. These fish form monogamous pairs that last a lifetime, partners that swim within 1 meter of each other for years, synchronize feeding patterns, sleep nearby, and demonstrate measurable stress behaviors when experimentally separated in the laboratory. But monogamy alone would not be sufficient. Each species of butterfly fish has a dark spot that mimics a false eye positioned near the tail, while the real eye is camouflaged by a vertical dark band. Predators that always attack toward the fish's head are disoriented by the illusion and bite the wrong end, giving the pair crucial fractions of a second to escape together in the opposite direction. They survive with fidelity and with deception. And both, at the same time, are absolutely real. The Moorish idol, Zanclus cornutus, is one of the most visually dramatic creatures of the reef. Vertical stripes of black, white, and yellow, a dorsal extension in a filament that can exceed the length of the body itself, and a presence that underwater photographers consistently describe as theatrical. But there is a reason this fish almost never appears in public aquariums. No aquarium in the world has managed to keep it alive for more than a few months in captivity, despite decades of attempts. Science still does not fully understand its diet. It is known to include specific calcareous sponges and sessile invertebrates that are difficult to reproduce artificially, but nutritional substitution attempts have systematically failed. The Moorish idol is a reminder that human arrogance in believing it can replicate complex ecosystems inside glass tanks has rigid limits. Some creatures only exist whole within the system that created them and do not survive the isolation we call conservation. In one of the most absolute reversals of parental role in the animal kingdom, the male Bangai cardinal fish, Pteropogon cauderni, incubates the fertilized eggs inside its own mouth for 22 days without feeding once. Not because prey is unavailable, but because opening its mouth would mean losing the offspring. The male remains still for weeks, with its mouth slightly open for egg oxygenation, while the female, free from the responsibility of incubation, feeds normally nearby. When the young hatch, they remain inside the father's mouth for a few more days before being released as perfect miniatures of the adults, already capable of surviving independently. The male loses on average 30% of its body mass during the incubation period. It recovers within weeks, and the following season it repeats. Sacrifice not as tragedy, as routine. What for us would be exceptional, for him is simply the way life works. The fine white sand beaches that define the imagination of tropical paradise, Maldives, Caribbean, Hawaii, were not deposited by ocean currents nor eroded from cliffs. They were manufactured by a fish, the parrotfish, Scarides p. has teeth fused into a calcified beak with hardness sufficient to scrape directly from the coral skeleton, ingesting the calcium carbonate along with the coral's organic tissue, digesting the organic matter and excreting the carbonate as fine sand in white clouds that settle and accumulate. A single adult individual produces up to 90 kilograms of sand per year. A healthy parrotfish population on a reef produces more sand than any local geological process. But with ocean warming destroying corals, the species' food base, and overfishing reducing parrotfish populations by 60% over the past 3 decades, the beaches of the future may be narrower, darker, and rockier. Paradise depends on a fish that most people have never seen. The cuttlefish, Sepia officinalis, does not see colors. Its eyes have only one type of photoreceptor, making it functionally colorblind in a spectrum that would be mediocre even for a dog. And yet it produces on its own flanks the fastest, most complex, and most dynamic color patterns of any animal on the planet, alternating between zebra stripes, mosaics, waves, and flashes in less than 300 milliseconds, using more than 200 independent pigmented cells per square millimeter of skin. Science has not yet fully resolved this paradox. The most accepted hypothesis is that the cuttlefish perceives light wavelengths through photoreceptors distributed across the skin itself, in parallel with ocular vision, in a form of sensory perception without equivalent in any other animal. Each pattern has a specific function: camouflage, courtship, threat, prey hypnosis. In 1 second, the same animal can display perfect camouflage on the left side of its body, while signaling aggression on the right, communicating different messages to two simultaneous interlocutors. The octopus, Octopus vulgaris, has 3 hearts, blue blood oxygenated by hemocyanin instead of hemoglobin, and 2/3 of its neurons distributed across 8 arms, which make independent motor decisions without consulting the central brain. Each arm solves local tactical problems, while the central brain plans overall strategy, a distributed neurological architecture that robotics engineers actively study to develop flexible robots without rigid structure. But the capacity that most disturbed science was documented in 2009. Octopuses collect halves of coconuts, Cocos nucifera, from the ocean floor, carry them under their body while walking bipedally on their back arms, and assemble them as portable shelter when needed. Tool use with anticipatory transport, implying future planning. An animal without a skeleton, living at most 3 years, that never knew its parents and therefore could not have learned culturally, reinvented the tool on its own. Intelligence, it appears, does not have a single form. For decades, the shark, Selachimorpha SPC, was narrated as the villain of a story that was never its own. The ecological reality is radically different. As an apex predator, the shark selectively removes the sick, slow, and genetically most vulnerable individuals from prey populations, preventing disease proliferation and maintaining the evolutionary pressure that keeps species healthy and adaptable. Without sharks, mid-level fish populations explode. Algae grazing on coral increases uncontrollably, and the ecosystem enters cascading trophic collapse. a phenomenon documented in detail in regions where overfishing has locally eliminated sharks. More disturbing still, science discovered that shark blood contains compounds called squalamines, with antibiotic and antiviral properties that the pharmaceutical industry studies as an alternative to conventional antibiotics collapsing under bacterial resistance. The animal that films taught us to fear may literally be the next source of medicines that will save human lives. Off the southern coast of Australia, in the temperate kelp forests, there exists a creature that evolution shaped with such precision to its environment that decades of research were needed to confirm it was an animal and not a drifting fragment of vegetation. The Leafy Seadragon, Phycodurus Eques, and the Weedy Seadragon, Phyllopteryx, Taeniolatus, possess leaf-like appendages that mimic in shape, color, and movement the algae among which they live, a camouflage so perfect that predators pass within centimeters without detecting them. Like seahorses, it is the males that carry the eggs, attached directly to the ventral surface of the body rather than in a closed pouch, and that oxygenate them with gentle tail movements for weeks. Entire populations of these animals have been discovered and lost again as the kelp forests they inhabit retreat with the warming of Australian coastal waters. They are so perfectly integrated into their habitat that when the habitat disappears, they disappear with it, invisible even in their own vanishing. Bottlenose dolphins, Tursiops truncatus, possess something that science hesitated for decades to name for what it is: language. Each individual develops a unique identity whistle in the first months of life, a proper name that other group members learn, memorize, and use to refer to the individual even in its absence, in a referential vocalization implying the concept of individual identity separate from the emitter. Isolated populations develop distinct dialects, vocalization patterns that differ from group to group with the same consistency that regional accents differ in human languages, and that are culturally transmitted to offspring by imitation. The Convention on Biological Diversity recognized in 2013 that the destruction of the ocean's acoustic habitat by naval engine noise, military sonar, and oil drilling represents a direct threat to the communicative capacity of these species, interfering with identity calls, hunting coordination, and communication between mother and calf. We are silencing conversations that began before human words existed. The humpback whale, Megaptera novaeanglii, undertakes the largest documented mammal migration on Earth, up to 8,000 kilometers in a straight line, from the nutrient-rich polar waters of the South Atlantic to the shallow, warm waters of the Brazilian coast, where they arrive without eating to give birth and nurse their calves in the calmest and warmest waters available. The whales do not eat during the 4 to 6 months they spend in tropical waters. They live off the fat accumulated during months of Antarctic feeding, losing up to 1/3 of their body mass. The calves are born at 4.5 meters in length and gain up to 45 kilograms per day, nursing on a milk of 45% fat, the most caloric substance produced by any mammal. The choice of Brazilian waters is not random. The specific temperature and salinity of these regions coincide with conditions that science still studies to understand why they reduce neonatal mortality. 8,000 kilometers to find the right place to begin a life. The leaf scorpionfish, Taeniolatus triacanthus, solves the problem of survival without speed, without attack venom, and without active camouflage, simply by becoming invisible through perfect stillness. With its laterally flattened body, covered in filaments that imitate algae and necrotic coral tissue, this fish sways gently in the rhythm of the currents, synchronizing its movement with the surrounding vegetation with such precision that prey passes within centimeters without triggering any escape response. Then, in an attack lasting less than 16 milliseconds, one of the fastest of any vertebrate, it opens its mouth, creating a negative pressure chamber that sucks the prey inside before any neural signal can process it. It exists in colors ranging from white to yellow, from pink to black, depending on the local substrate, and changes color progressively over weeks as it changes environment. It is not the fastest, not the largest, not the most venomous. It is simply the most patient. And in the ocean, patience is frequently the most lethal strategy. The orcas, Orxinus orca, of the South Atlantic have developed a hunting technique that science can only describe with a word it rarely uses for non-human animals: culture. Specific groups of orcas have learned to create intentional, synchronized waves, swimming in parallel formation at high speed and diving in unison to generate waves that sweep seals, Otaridae sp. and penguins off floating ice platforms, throwing them into the water where other group members wait. The technique is actively taught by adults to calves, who spend months practicing imperfect versions under maternal supervision before being permitted to participate in real hunts. Groups of orcas that have not developed this technique, even living in the same region, have never acquired it by observing other groups, revealing that knowledge is encapsulated in closed cultures that do not diffuse freely between populations. They are societies with exclusive traditions. with intangible cultural heritage, with knowledge that is lost when the group becomes extinct. At 1,000 meters depth, where pressure equals 100 atmospheres and temperature remains above zero by fractions of a degree, the deep ocean performs the most critical function for the survival of human civilization. And the least understood, it absorbs 90% of the excess heat produced by the greenhouse effect, and 1/3 of the carbon dioxide emitted by the burning of fossil fuels since the Industrial Revolution. Without this silent absorption, surface temperatures would already be 3 degrees Celsius higher than they are today. Conditions that would render large parts of the planet's inhabited regions uninhabitable. But this service has a cost. A warmer ocean expands its volume, raises sea levels, acidifies with the absorbed carbon, corroding the skeletons of corals, oysters, crabs, the entire base of the marine food chain. The bioluminescence flashing in the abyss, the sardine schools spiraling in formation, the reefs that built cities for 200 million years. All of this operates within temperature margins that humanity is compressing at a speed unprecedented in the planet's geological history. The ocean still breathes, still absorbs, still holds, but every capacity has a limit, and the bill for what has been deposited into it, in heat, in plastic, in carbon, in destroyed silence, will arrive. Not for the ocean, for us. The clownfish still dances in the anemone. The Mandarin fish still rises at dusk. The whale still crosses 8,000 kilometers to give birth. The orca still teaches its children. The coral still builds. The ocean has not stopped. But it is changing, faster than at any other moment in the last 3 million years. And you who watched all of this until here are no longer a spectator. You are a witness. A witness has responsibility. Share this with someone who still does not know what is at stake. Because what happens at 1,000 meters depth decides what happens in the city where you live. The ocean gave you the air. Now it is your turn.